In this example, I'm going to show you how to find the area of the region that is bounded by the graph of two functions. So in this case, we have f of x equal to 2x plus 1, and g of x is x squared plus 1. So I graph the function here, over here on the right hand side, and we can see that the function f is the upper graph and the g of x is the lower graph. Or sometimes we call this the outer and the inner. So in other words, f is greater than g. So then next we're going to find the point of intersection. And you can see right away right here that is where, if your graph is accurate, then you can see right here two graphs intersection at the point 0, 1 and a point 2, 5. Now if you don't know how to graph two functions, for example, we can always find the intersection points, which is mean where the two functions equal to each other. The only way the two graphs that cross each other is where two functions are the same. So that's really tell us that if you want to find the points of intersection of a two function, we set the function f equal to the function g, and we solve for x, and that will tell us exactly where the points of intersection. So I see that we have parabola, we have quadratic equation, so we minus 2x minus 1 both sides. We got x squared minus 2x, and then we factor out the x because x is the common factor. You see you have x here and x there, so x must be the common factor. So I get x equal to 0 or x minus 2 equal to 0, which is x equal to 0. So that means this is where exactly the two graphs cross. So you see exactly, you can confirm with the graph here, this is where x equals to 0 and 2. So, and we know that f of x is greater than g of x because the function f is the upper function and g is the lower one. Or you can say that f is the outer and it's the inner of your area. It's the area here. So now we go ahead and set up our integration. We're going from 0 to 2. And since f is greater, so I have 2x plus 1 greater function minus a small function, which is g x squared plus 1 by using the theorem. So now, before we can do anything, I'm going to simplify the integral a little bit nicer. So I got minus x squared, right, and then plus 2x. Then I got minus go inside here, so I have minus 1, then plus 1, so it is 0. So dx. Now we got minus x to the cube over 3 plus 2x squared over 2 and before we do anything, I see that we can cancel out of 2, so why not do that? So now we're going to evaluate the limit. So we take the upper limit minus the lower limits. What we mean by that is we take this 2, put inside the x, plus 2 squared, the upper limit, minus a lower limit. Put a 0 in here. Oh, it's nice. I have all 0, so it's disappear. So we get okay. So you can look for LCD here. I have 3 and then 3. So I got minus 8 over 3 plus 12 over 3. So we got 4 over 3. That is the area of your answer. Now let's say that if you have two functions, they give you the two functions of f and g or whatever, and you don't know how to graph, then the question is, how do we determine which one is greater, which one is smaller, or which one is the outer function or inner function? Remember, outer function means it's greater one, because look at here. F is outer or upper graph, so therefore f is greater, and g is lower graph, so it is smaller. Now let's say we have a problem that's very complicated. We have no graphing calculator, and it takes so long to graph. How can we determine if which one is greater? So it's extremely easy. First, you have to determine where is the points of intersection, and that's easy. I just showed you early. To do that, all you have to do is set two functions equal to each other, and you solve for x. That is the points of intersection. And then from there, you pick up one value between 0 and 2. Don't pick 0, don't pick 2, because those are the point where the function equal to each other. So pick like somewhere between 0 and 2. I would pick 1, because it's easy to work with. You can pick 0.5 if you want, but I don't care. I don't like decimal or fraction. So I pick 1. And what you do is you pick 1, and you evaluate. You evaluate the function f at 1. So you evaluate a function f at 1, and you evaluate the function g at 1. So which is like 2 times 1 plus 1 equals to 3. And then for this one, I have 1 squared plus 1 equal to 2. You see that when x equal to 1, which is somewhere in the middle here, the function f is 3, and the function g is 2. So you see that the f is always greater than the function g. That means the function f has to be the upper graph, and g is lower graph. And based on the theorem, we always take the upper graph minus the lower graph, or the biggest function minus the lower function. So right here, we confirm that using tiny calculation. You can tell that f is the function is greater than g, and g is a smaller function. And from there, you can set the integration, take f minus g, and then we go using the limit.